Hello everybody. In this video session, we will solve the problems on series and parallel connection of resistances. This is the given statement. Two resistors connected in parallel across 100 volt supply take 10 ampere from the line. Power absorbed in one coil is 600 watt. What is the resistance of other resistor? So usually in such problem, circuit diagram is not given. So first we should draw the circuit diagram. Now as you can see from first line, two resistors connected in parallel. So there are two resistances which are connected in parallel. So these two resistances are connected in parallel. Let us call resistance of first resistor is R1, resistance of second resistor is R2. They are connected in parallel, meaning there are two common points. They are connected in parallel across 100 volt supply. Now here across these resistors there is a supply voltage of 100 volt. Now this is the supply voltage, V equal to 100 volt. So we can write the data. Supply voltage is given, total voltage, that is 100 volt. Now we know the property for parallel, voltage will remain same for all the parallel connected resistors. Now what they have mentioned next, take 10 ampere from line. So from line meaning they have given the total current, this current. So total current taken from line, it is 10 ampere. So IT, it is mentioned as 10 ampere. Now next, what they have mentioned, power absorbed in one coil is 600 watt. So we can take power absorbed by either R1 or R2. They have not mentioned specifically. So power absorbed in one coil, let us say P1, it is 600 watt. And what we have to determine here, what is resistance of other resistor. So R2 equal to question mark. Okay, so from the given problem statement we have drawn the circuit diagram and we have write the given data. Now how to solve such type of problems after drawing the circuit diagram and writing given data? So look for the given data. Now here total voltage is given, total current is given, and power consumed by one of the resistor is given. Now we can make use of the given data to determine some unknown quantities. Now here as you can see, total voltage is 100 volt and total current is 10 ampere. Now by making use of these two quantities, we can determine equivalent resistance or total resistance, because we know by Ohm's law total voltage V, it will be equal to total current into R equivalent. Okay, so based on the given data, try to find the other quantities. Now we know value of V, it is 100 divided by total current, it is 10. So R equivalent, it will be 100 upon 10, that will be 10 ohm. Let us call this as equation number 1. Okay, now next what they have mentioned, they have mentioned the power consumed by one resistance. Let us say power consumed by resistance R1, it is P1, which is 600 watt. Now we know three formulae for power. So what are the three different formulae for power that is required? So first is V into I, basic formula. By Ohm's law we can write I square R, and if you put I equal to V by R, it will be V square by R. There is one more formula in terms of energy, but here energy is not mentioned. So we have to choose which formula we should use for power. Now as you can see here, value of R1, it is not mentioned to determine, but we cannot determine R2 directly without determining R1. So first we should determine this resistance R1. Now how to determine this resistance R1? Now we know total voltage across resistor 600 volt, and we know the power consumed by resistor, meaning V is known, P is known, and to determine we have to determine R. Now which formula we can use? As you can see, P, V and R. So we can use third formula, P equal to V square by R. Okay. Now I will write here. So out of these three, we can use this formula. So P equal to V square by R. Now power consumed by first resistor is mentioned. So P1, it will be equal to V square upon R1. We should not write here V1. There is no necessity because for parallel, as you know, voltage remains same. Now we can determine R1. So it will be equal to V square. So how much is V? It is 100 divided by P1, that is 600. Now if you simplify this, you will get 16.67 ohm. Now let us call this as equation number 2. Okay. So what we have done? So from voltage and total current, we have determined the equivalent resistance. So we have got it as 10 ohm. Now from total power, power consumed by one resistance and voltage, we can determine resistance of that particular resistor. So that we have got as 16.67. Now our main aim is to determine R2. Now from equation 1, we know value of R equivalent. From equation 2, we know value of R1. Now if you see, for parallel combination, we can write formula for equivalent resistance. So what is the formula for equivalent resistance in case of parallel? 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2. Okay. Now from equation 1 and 2, we can substitute these values. So 1 upon 10 equal to 1 upon 16.67 plus 1 upon R2. Okay. Now if you simplify this, so while simplifying, 1 upon R2, it will be equal to 1 upon 10 minus 1 upon 16.67. If you take 10 raised to minus 1 minus 16.67 raised to minus 1, you will get 1 upon R2. Again you take raised to minus 1, inverse of that, you will get R2. And if you simplify this, you will get R2 equal to 25 ohm. Okay, so that is our final answer. So what we have done here, so by total voltage and total current, we have determined total resistance, and from power consumed by one coil, we have determined resistance of that coil, R1. Now we know one more equation for R equivalent, 1 upon R equivalent equal to 1 by R1 plus 1 by R2. We have substituted value of R1, and then we have got R2 as 25 ohm. Now this is the one way to solve the problem. There are more than one way to solve the problem. Now we can solve the problem by Kirchhoff's law also, or by other method also, but here this particular method, it is relatively easy to understand. So hope you have understood how to solve the problems on series and parallel connection. Thank you.